In this video, we are going to look at another method that we can use to solve for quadratic equations. Completing the square. So we are going to use completing the squares when the other methods that we've learned so far cannot be used to solve a quadratic equation or quadratic function. So we've learned that we can solve by graphing, we can solve by factoring, and we can solve by finding the square root. So when we have a quadratic equation and we cannot use those methods to solve that quadratic equation, we can then look at completing the square. So we are going to learn how we can take an equation and manipulate it so that we can solve it using completing the square. So let's take a look at how we do that. Looking at this equation, x squared minus 4x minus 8. So can we factor? We would be looking for factors of negative 8 that would add up to negative 4. There are no factors of negative 8 that add up to negative 4. So factoring wouldn't be the best method to solve for this. What about using a square root? Well, again, we have this x term right here, so solving by taking the square root isn't going to work here either. It would get really messy. So we're going to use another method called completing the square. So what we do is we complete the square to form a perfect square trinomial. One set of parentheses times another set of parentheses. We're trying to find a perfect square trinomial. So in order to do that, we're going to use completing the square. So here's the steps. So first step is we're going to move the constant term to the other side of the equation. We want the constant term to be all alone on one side of the equation and the x squareds and the x terms to be on the other side. So let's do that. So we need to move this negative 8 to the right side. So in order to do that, we're going to add 8 to both sides of the equation. So this is step 1. And when we move the constant term to the other side of the equation, just by adding it, we're left with x squared minus 4x equals 8. So really, you don't have to put the plus 8 if you can just look visually and see if I need to move the constant to the other side, that just means it's going to be equal to 8. So we've done that. Step 1 is done. Now it says take half of the coefficient of the x term. So we're going to focus on the coefficient of the x term, which in this case is negative 4. We're going to take half of it. So we're going to divide it in half. So I'm going to rewrite the equation here with a space too so that we can start completing the square and doing all of our steps. So I'm going to write the equation minus 4x. I'm going to keep a space. Set it equal to 8. Because what we're going to do is we're going to take the coefficient of the middle term, going to divide it by 2. Divide it by 2. So when I divide that by 2, I get negative 4 divided by 2. And I'm going to add that. I'm going to add this, and then I'm going to square it. So let me read through those directions again. It says take half of the coefficient of the middle term, the x term. The coefficient is a negative 4. Take half of it. So I took that coefficient negative 4 and I divided it by 2. I took half of it. And then square it. So here I put parentheses around it to say we're taking this entire term and squaring it. And then we need to add that value to both sides of the equation. Think of it as like a seesaw, a teeter-totter. Whatever we do to one side, we have to do to the other side. So I'm going to add that same value, that negative 4 divided by 2, and then square it. Whatever I do to one side, I have to do to the other side. All right, and what do we get when we do that? So let's do the math now. So x squared minus 4x, what is that? Negative 4 divided by 2 is negative 1/2. Let's do the math over here if you need to see that. Is negative 1/2, but then we had to square that. Or, I'm sorry, that's not 1/2. That should be negative, negative 2 squared. Negative 4 divided by 2 is negative 2. Negative 4 divided by 4 is negative 2. And then when I square that, negative 2 times negative 2 is 4. So really what I'm doing is I'm adding 4. And then remember what I do to one side, I have to do to the other side. Clean that up. So now I've got x squared minus 4x plus 4 equals 12. And now if we look at the left side of the equation, so let's rewrite what we've got here. I've got x squared minus 4x plus 4 equals 12. Now, this is a perfect trinomial. That what we have on the left side of our equation is a perfect trinomial. This x squared minus 4x plus 4, that's a perfect trinomial. So if we were to factor that, we were looking for factors of 4 that add up to negative 4. So factors of positive 4 that add up to negative 4 would have to be negative 2 and negative 2. So look what we would have here. X minus 2 times x minus 2. That's a perfect square. I can just rewrite that as x minus 2 squared, right? Because it's the same terms in the set of parentheses, so I can just square that and set that equal to 12. And now we're left, we've completed the square, and by completing the square, we've arrived at a perfect square trinomial, We've got that now, our perfect square trinomial. It's right here. X minus 2 squared. That's a perfect square trinomial. And we're not done yet. Now we've got an equation that looks very similar to what we've been solving on the past couple of slides, right? Where we can use a square root now to solve and find the final answer by completing the square. Now that we've completed the square, we're ready to solve by taking the square root. So we want to solve for x. So if we want to solve for x, let's take the square root of both sides, just like we've been doing. And when we take the square root of both sides, now we're left with x minus 2 equals square root of 12. There's no perfect square, is there, of 12? So let's just leave it as a square root, because if we were to take the square root of 12, we would get a decimal. So I know I have a positive and a negative version of the square root of 12. And then to solve for x, I'm just going to add 2 to both sides, and I would get 2 plus or minus the square root of 12. That would be our final answer. And we were able to come to our final answer by completing the square. We had to first complete the square because before we could solve, that's an equal sign, by taking the square root. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. We're going to look at one more example of completing the square, and then we'll stop. All right, so we have this equation, x squared plus 10x equals negative 9. We can't solve by factoring. So what we can do, and we can't solve yet by just taking the square root because we've got that x term. So before we can take the square root to solve, we need to complete the square and get it into a perfect square trinomial. So let's do the steps. Let's go through the steps again. It says first move the constant term to the other side of the equation. The constant term needs to be all alone. It's already done in this case. So that's already done. Step 1, done. Step 2, take half of the coefficient of the middle term, so divide it by 2, and then square it. So we are going to take this middle term and divide it by 2, and then square it. And then whatever I do to one side, I have to do to the other side. So I'm going to add to it that 10 over 2 squared. So what is that? What am I really adding to both sides? 10 divided by 2 is 5. 5 squared is 25. So really what I'm adding to both sides is 10 divided by 2 is 5. 5 squared is 25. What I'm really adding to both sides is 25. So what is negative 9 plus 25? That's all the math I need to do because there's nothing I can add on my left side, but I do need to go ahead and add that negative 9 plus 25. So what do I really get there? I've got x squared plus 10x plus 25 set it equal to negative 9 plus 25. And that gives me 16. What I think most students make an error when they're doing completing the square is they forget to take this term and add it to the other side. Remember, whatever we do to one side, we have to do to the other side. We add 25 here, we have to add 25 here. It's a teeter-totter. We need to keep it balanced in the middle. So now I'm at a point where now I can factor. And create a perfect square trinomial. So I'm looking for factors of 25 that add up to 10 to help me factor. And it looks like that would have to be 5 and 5. And when I'm factoring a perfect square trinomial, I know I'm going to get the same number because I want to create that perfect square trinomial. So we know that my factors would have to be x plus 5 times x plus 5 and equal to 16. And then I know I can rewrite that same quantity in my two sets of parentheses. So why not just rewrite that as x plus 5 squared? It's the same thing. And that way, I'm at a point now where I can take the square root and solve for x. There's a square, take the square root of both sides. What do I get? What do I get? So now I'm solving. Well, now I've just got x plus 5 equals 16, or x plus 5 has to equal negative 16, because when I take this square root of 16, I'm going to get a positive, oops, not positive 16, positive 4. Square root of 16 is 4, and then a negative 4. So square root of 16 is positive 4, and the square root of 16 is also a negative 4. And then solve by subtracting 5 from both sides. I get x equals 4 minus 5 is negative 1. When I'm subtracting 5 from this side, I've got negative 4 minus 4, and I get x equals negative 9. So there's my two solutions. So completing the square gets us to a point where then we can take the square root. And that wraps up this video on looking at some examples of how we can use completing the square to solve for quadratic functions.